These 6 identities are given to you on your formula sheet, and you're going to have to recognize when they may be useful to you. Okay? But we can, as I said, determine the exact value for cosine of 15. What are the angles that we know from our triangles? 0, 35, 30, 45, 60, and 90. We have special triangles for that. Can I make 15 degrees out of a pair of those? I can either use cosine of 45 minus 30, or I could use cosine of 60 minus 45. So I'm going to have to use the difference identity for cosine, which is this one here. Now I'm going to use the 60 minus 45, but you're going to get the same answer if you use the 45 minus 30. So we have, this is equal to cosine of 60. Sure, I've got it right. Cosine of 45 minus, plus cosine, again, sine of 60 times sine of 45. All I've done, A for me was 60, B was 45. Now I'm going to go to my triangle. Cosine of 60 degrees is 1/2. Cosine of 45 degrees is square root 2 over 2. Sine of 60 degrees is square root 3 over 2. Sine of 45 is square root 2 over 2. So I'm replacing this entire thing with square root 3 over 2. And you quite a mistake we often make is just write sine of square root 3 over 2. No, sine of 60 is square root 3 over 2. From here it's just some multiplication, top times top, bottom times bottom. Square root 3 times square root 2 is 6. There is the exact value, not what I expect you to memorize or remember. That is the exact value for cosine of 15 degrees. Now here, this is actually one of the identities that we're going to, that we are not going to use too much of here, but we want to, this is a it is a coterminal identity. They have the same terminal on it. Now, we have cosine of an angle minus an unknown angle. So here we're going to use the difference identity for cos, which we just used. So this is going to be equal to cosine pi over 2 cosine theta plus sine pi over 2 times sine theta. So again, going back to our difference identities for cosine, A is your pi over 2 and B is your theta. Now, what is the cosine of pi over 2? what is the cosine at that point? The point is 0, 1. The cosine at that point is 0. I have no idea what cosine theta is, because I'll just leave it in. The sine at that point is 1. 0 times anything is 0, so this equals 2 sine theta. Again, we can expand things, we can contract things. Now, this here basically tells us if we've got this arm here, and I know what the cosine value is, never mind, if I want to know what the cosine of this angle is, I just have the sine of this angle there. They're related. Cosine and sine are related within that 90 degrees. There's a bunch of other coterminal angles for that. So that's a proof. So we've proven that we now could use this in anything that I want in the future. Now I want to know the exact value of sine of x minus y, and I don't give you the values for x and y. I just tell you that the sine of x is 3/5 and the sine of y is negative 5/13. I've given you 2. Now we want sine of x minus y. Well, we can't just plug the angles in here and get an exact value for that. We could figure out inverse sine of 3/5 and we could go from there, but that's not going to give us what we want, because we want the exact value. Exact value means using our identities. The difference identity for sine is sine A cos B plus sine B cos A. No, it's not. Please erase the positive sign there and put a negative sign between them. The difference identity there is got a negative between it for sine. It is positive for cosine, but it stays the same for sine. So in this case, sine x cos y minus sine y cos x, and I am going to go back to make sure I've written that down correctly. Yes, I have. Now, that means I've got sine x, I could put 3/5 here, and I could put negative 5/13 there. Questions? Did I make a mistake? If it's possible. I don't have cos x and I don't have cos y. But we're going to go back to the strategy we used last unit. We're in the first quadrant, 0 to the power over 2. Okay, sine is opposite over hypotenuse. Using Pythagorean theorem, I know that that's going to be 4. I also use the fact that that's a Pythagorean triple. 3, 4, 5. 3 squared plus 4 squared is equal to 5 squared. So now I can find cosine of x, which is 4/5, positive. I have another triangle in the quadrant 3. Sine again is equal to opposite over hypotenuse. This happens to be another Pythagorean triple. Okay. So 5 squared plus 12 squared is 13 squared. 25 plus 144 is 169. Use Pythagorean theorem to get there. That's fine. Now, cosine of this angle here is negative because cosine is negative in that quadrant. And it's 12 over 13. Minus sine between them. So I don't want you can, go ahead, you're not going to get an exact value for this. Maybe you will, but no, because you'll have to round it. What we have is negative 36 over 65 minus negative 20 over 65. So we have negative 16 over 65. So when you're asking for a difference or a sum of something, or in this case sine, but do everything else, you are probably going to have to find the other identity, the other parts of this, whether it's tan or cosine, etc. So using this idea of drawing a triangles in the proper quadrants, using opposite adjacent hypotenuse to find the other 6 or other 5 ratios, and then plug it into the formula. So remember, sine of x is 350, 3 over 5, so I get to plug it in. Now, here we have the big thing, we want to collapse it. We have sine of 100 cos 10 plus sine of 100 sine 10. Which one of these identities best matches that? We have sine of an angle, cos of an angle, plus cos of an angle, sine of an angle. Which one is that? Which of these identities is best, does that work with? Sine A, cos B, sine B, cos A. Now it's plus, so that means it's going to be sine of A plus B. So this gets simplified down to sine of 100 sine of 100 plus 10. You're able to do those. And then if I wanted, we don't have an exact value, I could ask you to punch that into your calculator, but in this case, a simple number, that would be what I would write for this one. Now, if I had a negative sign between that, then I would have sine of 90. We know sine of 90 is 1. We have an exact value for sine of 90. We don't have one for sine of 110. Oh my, this is ugly. No, it's actually not that ugly. Now, if I think about this ugly, I'm going, oh my. First thing I saw here. However, we have cosine of pi over 4 minus theta, cosine of pi over 4 plus theta. Here we have pi over 4 minus theta, pi over 4 plus theta. What this actually has is cosine A, cosine B, minus sine A, sine B. Yeah, they're ugly looking angles, I'm not arguing with you there, but they are angles. So I can think of it like this. Do I have an identity for cos A, cos B minus sine A, sine B? Cos A, cos B minus sine A, sine B. There's my identity. It's the sum identity for cosine. So, cosine of A, which is pi over 4 minus theta, plus pi over 4 plus theta, which is our, well, what I call my B value in this case. So we don't want to do all that other stuff. But I was able to see that we have two angles there. We're looking angles, but two angles. Now we can do some gathering of like terms inside my brackets. Pi over 4 plus pi over 4 is pi over 2. Negative theta plus theta is 0. So this entire ugly looking expression works out to be cos pi over 2, which is 0. I was able to recognize that we have angles here. Now the first time that I did this one is I tried to explode every one of them. But I have to recognize that this here, we have two angles. Just work this out. Now here, I want this to be a single trig. I don't want to actually evaluate this one yet. Here I've given you something, and I want to see if I can use my sum or my difference identities to make it a smaller something. We have 1 plus tan pi over 4, tan pi over 3, over tan pi over 4 times tan pi over 3. Going back to my sum or difference identities, actually I must have a negative sign. This is a negative sign, not a multiplication sign. Does this look like does it look like this one, or does it look like that one? Well, we have this here is on the bottom, and this here is on the top. Now, if I want it to look like I want, so what I actually have there is, this is the reciprocal of what I have on the bottom. I flip it. Now I've got tan of an angle minus tan of an angle over 1 plus tan of an angle times tan of an angle. We'll go back there in a minute. That's this guy here. Okay, so I can replace everything I have in there with tangent A minus B. So we have 1 A is pi over 4, and our B is pi over 3. We know this because it's tangent A minus tangent B. Now, what's the reciprocal of tangent? Reciprocal of tangent is cotangent. Now, I want to tidy that up. I want to simplify that down to tangent of one angle. Well, I need a common denominator to do this. So this is 3 pi over 4, or over 12. Minus 4 pi over 12. Cotangent of negative pi over 12. That's what that has simplified down to. Now, I don't know what cotangent of pi over 12 is, so that's the simplest it's going to get written down to. Steps going through that, I basically had to recognize that we had a reciprocal here. This isn't exactly like what we have on our formula sheet. I had to flip it. So I had to take the reciprocal, and that's how I wrote it here. And then I went ahead and replaced this with my cotangent and brought it down to one angle. Cotangent of one angle. Now, cotangent of 5 pi over 12. Well, again, that is going to be 1 over tangent 5 pi over 12. Since we don't have a sum or difference identity for cotangent, although we can quickly figure it out, now we have to figure out, how do I get 5 pi over 12? The angles that we know are 0, which isn't going to help us. Pi over 6, pi over 4, pi over 3, and pi over 2. And we know there are continuations and other ones, but how am I going to get 5 pi over 12 by either adding or subtracting some of those angles? Add those two together. So this is going to be 1 over tangent pi over 6 plus pi over 4. And to be perfectly honest with you, I can never remember what tangent identities are. So we want plus tan A plus tan B over 1 minus tan A tan B. So I'm going to substitute A is going to be pi over 6 and B is going to be pi over 4. One over tangent pi over 6 plus tangent pi over 4 over 1 minus tangent pi over 6 tangent pi over 4. So now we get to sub things in. tangent pi over 6. Here's my pi over 6. Tangent is opposite over. Okay, so I'm going to use 1 over square root 3 for that. Plus 1. And then tangent of pi over 4 is 1. Alright, I hate working on that fraction. That fraction is driving me nuts. So I'm going to flip it. It's going to be 1 minus 1 over square root 3 over 1 over square root 3 plus 1, which is not exactly where we are. What do you need to simplify the numerator and denominator? You need a common denominator. So this can be written as square root 3 over square root 3, as to that. So we have square root 3 minus 1 over square root 3 over 1 plus square root 3 over square root 3. When we flip that to tidy it up, our square root 3's disappear. Our numerator, square root 3 minus 1, and I'll just rewrite that guy in a different order. To get what we want. You are not wrong with what I had in blue here. Just ugly looking because we have fractions. So we had a little bit of work to do with a radical on a common denominator. I could have rationalized this, and if I rationalize 1 over square root 3, it takes a little bit more work to get to where we are. So, a lot of algebra, but you have those 6, your 6 sum difference identities. They are given to you on your formula sheet. The biggest problem is having to recognize when you need them. A lot of us reach for that calculator to do some questions. And if I want the exact value, you're not going to get an exact value out if you use a calculator. Attached to this is your homework.